To summarize arithmetic sequences from Unit 7, Lesson 2, we have a parking ramp, and it has the following parking space requirements. Each row has row 1 has 4 spaces, and each row has 2 more spaces than the previous row. So to complete the table, if row 1 has 4, the next row has 2 more spaces in that. So this would be 6, row 3 would have 8, and row 4 would have 10, and row 5 would have 12. Now we could do this for as many rows as you like, and sometimes if they ask you maybe what row 57 would have for spaces, you can fill it out the whole way. That's totally up to you. But our goal is to look at equations and make that easier for us. What type of sequence is this? Of course, since we're summarizing arithmetic, we would know it's arithmetic. But how do we know that? Well, it adds 2 every time. So when you see that it's an adding relationship between every term, that would make it arithmetic. So because it adds to each row. Then we want a recursive form. And remember, recursive has the subscripts, and we're using r sub n and r sub n minus 1. Sometimes a problem will indicate which subscripts you need to use. Now, of course, if n minus 1 and n are being included, n is like the current one, and n minus 1 is the last time row. So we would say, to get the next row, we would take the previous row, n minus 1, and add 2 to it. Whenever you make a recursive formula, you have to have your starting value. So we would say that r sub 1 equals 4. Now remember, that means when you plug in a 1, you get 4 because row 1 has 4 spaces in it. Now for a function formula, it's a little bit different. It doesn't have subscripts. We can use some of the same letters, and letters don't really matter. But since it says use R of S, we want to make an equation that when you plug in 1, you get 4. Always use your table to check if your equation for the function formula doesn't allow you to plug in, say, 2 and get 6, then your formula is incorrect. So thinking about this, one hint you have for function formulas, because it's growing by 2, that's kind of like a slope, if you will, when you're graphing a line. So our equation is going to have our 2, and we can put times n. Now, normally, this number, there's usually like a beginning number. Let's think about this. If I put 2 times 1 in there, 2 times 1 will be 2. To get to 4, I'd have to add 2 to that. So sometimes I make my function formula by just checking what would work on the table. Let's try plugging in 2. 2 times row 2 would be 4, plus 2 would be 6. And I know that works. I can check with 3. 3 times 2 is 6, plus 2 is 8. This is how I know this function formula is correct. Again, use your actual data or your actual table to check that. So now that we have our equation, this one works great, and this is probably what I would do most likely. There is an equation that sometimes they say if you want R of S, they might say you take 2 times n minus 1 and add 4. Now let's try it with our equation. If you put in 1, 1 minus 1 is 0, times 2 makes 0, and add 4, you get 4. This equation will work. Try 2. 2 minus 1 is 1, times 2 is 2, plus 4 would be 6. This equation works, but what it allows you to do, and let's highlight here, this last term, some people like to use like your starting number of parking spaces in the first row. That initial term matches up with your number of car spaces in the first row. So that can be useful, but you have to make sure that when you plug in row 1, you want someone to use this formula efficiently. So if someone wants row 36, they don't have to make this table. They can simply plug in 36 to these equations. Both of these equations work. Just look at the start value. This includes what your row 1 had for spaces. This one doesn't. You kind of have to go back to like what a row 0 would have and go back 2 spaces. Either of them will work, but you now have formula options for finding a further row, which helps when I want row 13. I'm going to use my first equation. So row 13 would mean I can plug 13 into any one of those now that I've checked those formulas. So I'm going to do 2 times 13 is 26, plus 2 would be 28. I now know there are 28 parking spaces in row 13, and these equations work to find that. Let's try 13 in here. 13 minus 1 is 12, times 2 is 24, plus 4 would be 28. Either equation works. Just please make sure that you check your original data to any of your function formulas to make sure they're right.